we've certainly found planets. We can tell quite a bit about the planet. First of all, we get its size. For the bigger planets, we actually get its mass. We get its density. We can tell you whether the planet is sort of a fluffy planet. We found some planets that are less dense than Jupiter, some planets, in fact, that have a density of styrofoam. Giant planets with very low densities. We're working our way from the big planets to the small ones because it gets more and more difficult as you go from big planets to small ones. And similarly, if you're trying to find planets in a habitable zone, then you've got to see them when they have long period orbits. The Earth takes a whole year to go around the Sun. We have to wait about 3 years, so we need 3 transits before we say, yes, we found something, let's verify it from the ground and announce it. So up to now we have announced about 5 planets. They're short period planets, and they're giant planets. This coming year we're making our observations to qualify these candidates.
So the LCROSS mission took advantage of a spent upper stage of the Centaur rocket that propelled us to the moon. And in this part of the graphic, the green line is the trajectory of the LCROSS mission. You see it flew by the moon and then went into a large elliptical orbit around the Earth. And finally it catches up to the moon after about 4 months and impacts the moon. 9 hours out from the moon, the separation we achieved was 4 minutes, so we are trailing 4 minutes behind. We targeted a permanent shadowed region at the south pole of the moon. After impact, the shepherding spacecraft flies at the impact site, gathering data real time, flying eventually through the debris cloud itself and impacting itself on the moon about 4 minutes afterwards.
By far, the fact that we're getting water spraying out of the moon Enceladus around Saturn has been dramatic. It indicates there's an underground, or there's an ocean there, under the ice. Maybe it's 1,000 feet of ice, but there's water there. And when there's water, there's a possibility of life.
And for me, I would say, to the other extreme, the coldest temperatures observed on the moon now by the Diviner mission, our instrument on LRO, are as cold as 28 degrees Kelvin. So those are temperatures colder than Pluto. So some of the coldest temperatures in the entire solar system are right in our backyard at the moon. And those are acting as fantastic cold traps, gathering material for billions of years.
First of all, space exploration requires very high technology. So we help our industries become technologically competitive with the rest of the world. We build the products, we invent the products, we build the jobs here in the United States. And we also, I think, provide the spirit of exploration that people in the world in the U.S. would like. They understand better their place in the solar system, their place in our galaxy.